So hello everyone and welcome back to Python Made Easy. So we are on the way to master Pandas library from scratch, and this is going to be the third video of this playlist. I already uploaded two videos. You can watch it before jumping to this video. So in this particular video, what we are going to cover? So we are going to cover today is interpolation, like fill missing values intelligently using some mathematical methods. Next thing is sorting. Sorting is like arranging values in ascending or descending order. So we will look at this and we will apply some statistical formulas that is known as aggregation in pandas. So we will look at that and we will group by columns with their properties. So group by is like applying some formulas or some rules to combine two or more columns together. So we will look at these topics today. So let's start with the first topic, that is interpolation. So interpolation is estimating missing values based on known surrounding data points. So if there is a missing value in a column, we will handle it by looking at its surrounding, like it's the value above the data point or the value below the data point. So we will fill the missing value based on its surrounding. So there are few methods like linear method, polynomial method, time-based method, and nearest method. So we will look at linear, polynomial, and nearest. Time-based is something we will look when we will work on time series dataset. So we will look this then. So today let's see linear, polynomial, and nearest. So this is the workplace. So first you need to import two libraries, pandas and numpy, and let's run this. So first let's describe the data set we are going to work with. So this is the data set for today's video. So here you can see that there are four columns: region, product, sales, and units, and few values inside it. Let's run this. So here you can see region, product, sale, and units are the columns, and these are the values. Regions are north, south, and east, and products are A and B. And here sales, there are two missing values in the sales column, you can see, and few units. So let's start with interpolation. So first we will see linear interpolation. So what is linear interpolation? Strategic line estimation between two known points. What is that? Let's see. So suppose you want to, here there are two missing values in the sales column. So you want to handle this with the help of interpolation. So let's see. So first access the sales column. So df and sales. So we got access to the sales column, and then dot interpolate. This is the method, and after that pass the way you want. Like here we want linear interpolation. So here method equals to linear, so that the interpreter got to know that we want to use linear method. And let's run this. See, you can see that the missing values in the sales column got filled, and here the missing value was at second row, here you can see, and here second row got filled by 225, and this is the mean value because the second row is between the first and third row. So first row has 150, third row has 300, and the mean of these two values is 225. And here you can see the second row got 225. Same as here, a missing value as fourth row, and the fourth row is between 3 and 5. So it got filled by the mean value of 300 and 180, that is 240. So this is the way to fill the values using linear method of interpolation. Next, let's look at polynomial interpolation. So first access the sales column, so df and sales. Next, same dot interpolate and then pass the method that is polynomial. So method equals to polynomial, method equals to polynomial, and then here you need to pass one more parameter, that is order. Okay, order equals to, you can give any value here. Suppose I provided order equals to 2. Let's run this cell and wait for the output. See, here you can see the sales column got updated by the polynomial method. Here you can see the second row got value as 218 point something and the fourth row got 287 dot something. So this is the way to fill it with polynomial method. And let's see the next method, that is nearest method. So do that with the same df and then sales column and then dot interpolate and then method equals to nearest. Okay, method equals to nearest, and let's run this. So here you can see the second row got the value 150 because 150 is its nearest value. Like the first row has value 150, so the second row also got 150 because of the nearest value. Here you can see the third row has 300, and because of that the fourth row also got 300 because it is the nearest value of it. So by these ways we can fill missing values inside a column using interpolation. Okay, here you can also store this inside another variable like df, and here you can create new column like sales underscore linear, because here you use linear method. So this and then okay, so it got stored inside this variable. Let's copy this and paste it here. Let's see what happens. See, okay, and here you can do the same with these columns. Like here you can store it inside another variable, and you can give it name sales underscore polynomial, because here we worked with polynomial method, polynomial. Okay, and when you run this, okay, and here provide polynomial again, sales underscore polynomial. And if you want to look at both the values together, like the previous value and the new value, then what you can do is here you can pass df and then you pass those both of the column names. Like first it was sales, so access sales column and comma, and then the sales underscore linear column. And when you run this, here you can see sales and sales underscore linear got together. Here you can see the second row has a null value, here it got filled. Here you can see that fourth row has a missing value and it got filled. So in that way you can see both the columns together, the previous and the new column. You can do same with this and this column also. Okay, do it on your own for understanding. Next thing is sorting. So what is sorting? So sorting is arranging values in ascending or descending order. So to sort values, we have two ways: sort underscore values and sort underscore index. So how we can do that, we will see. So sort underscore value means sort rows by one or more column values. Ascending equals to true or false. We can pass the parameter ascending equals to true or false to control the direction. Suppose we want in ascending order or descending order, so we can do by passing ascending equals to true or false. We will see that. By equals to accept list for multi-column sorting. If you want multi-column sorting, multiple columns together to be sorted, then you can use by method. Na underscore position, you can say highlights, or here you pass two parameters, last or first. When you pass first, then the null values will get printed at the starting of the column, and when you pass last, then the missing values or null values will get printed at the last of the column. Okay, in place equals to true, you have seen it in previous videos. Like if you pass in place equals to true, it modifies your original data set, and if you do not pass it, it creates a copy of the data set. So this is the thing. And sort in underscore index is sorting value by their index, or you can say row wise. Okay, so we will see this. So start with sorting. So first, let's see, we have first, let's access the df. So this is the df. We have let's see, we want to sort values by units, means product sold per unit. Means the, suppose the product is A and it got sold 10 units, the product is B and it got sold 8 units. So let's arrange this in ascending and descending order. So let's do this. So df dot and pass sort underscore values, sort underscore values, and then pass by equals to, this is the method, by equals to which column you want to sort. So like here you want to sort unit column, so units, and then pass ascending. So here you pass, suppose you want ascending equals to true. Okay, ascending equals to true. So let's run this. Here you can see it got printed in ascending order. Ascending equals to true means it got printed in ascending order. See 7, 8, 9, 10, 12 and 15. And when you pass ascending equals to false, ascending equals to false, let's see, it got printed in descending order. Here 15, 12, 10, 9, 8 and 7. So this is the work of ascending the parameter, and you can pass true or false based on your work need, you can say. So you can store it inside a variable, like here you want to sort, store it into like sorted underscore df, and let's run this, and let's print sorted underscore df, sorted underscore df. When you run this, okay, so this is the way to sort. So let's see how you can sort multiple columns together. So to do this, you have way. So first let's create a variable like multi underscore sorted. Okay, multi underscore sorted, and then first you need to pass df dot sort underscore values, sort underscore values, and then pass the method which is by, and by equals to, you want to do it by suppose units again, so pass here units. Okay, and then pass ascending, the parameter ascending equals to false. Okay, and now print sort multi underscore sorted, multi, here you can see multi underscore sorted, and now pass the columns you want to sort. So like here you want to sort it with region. Okay, you want to sort it with product, sorry, here forget string, oh sorry, just a moment. So here product and the units, so units, and when you run this, here you can see the things got sorted by the region, the product name, and the units. Here you can see east, then north, and then east again, and then south. So here you passed units, by equals to units, so it will sort based on units, and together you want to print the region and product column. So here you can see units 15, 12, 10, 9, 8, 7 means in descending order, and then here you can see the product and the region assigned to these particular units. So you wanted to print units, you want to sort the data set in by units, but you wanted to see the region and product assigned with those particular units. So you can do in that way. Here you got to know that 15 units are sold, but product A got sold 15 units and it is in east region, and product B got sold at 12 unit and it is in north region, and it is sorted in descending order. So this is the way to do it. There are more ways to do it. So like here I think I got something wrong, so let's keep it df underscore sorted here, and keep it df underscore sorted, because it is here we only sorted the values by a single column. Here you can see that only the units column got sorted, otherwise they all are shuffled. So if you want to sort by multiple columns, so what you can do it, so first create a variable multi underscore sorted, and then start sorting values. So df dot sort underscore values, and after that you pass by equals to, and then pass the column names. So suppose you want to sort with region and units, so pass units. Okay, and now pass ascending. Okay, so ascending equals to, here you need to remember that here you passed two columns, region and units, then you need to pass here two values inside the ascending parameter. Like first you passed true and then you passed false, and when you run this, okay, it got run, and when you print multi underscore sorted, then you can see that this is got your column got sorted by region and units. Here you can see the region is east, then north, and then south, because you passed region and the ascending is true for reason, then it is got in ascending order. And units, for units you passed ascending equals to false, so units got in decreasing order. But here you can see it got shuffled because the it there it is not possible to sort two columns and one in ascending, one is descending. It is not possible. So here you can see it got sorted in region column, and the units got you can say according to the region. Okay, so this is the way to sort multiple columns together. And when you run this, see here what we can do is, here let's print something else here, print, and what you want to print is multi-sorted, and then pass the column names, that is region and units. So pass only the column names so that you won't get the whole data set, you only want those columns that you sorted. So here you can see you got two columns, region and units. Region got sorted and units got sorted according to the region column. Okay, so these are the ways to sort values. Next is, here you can see that na underscore position. So let's see this. So df dot sort underscore values. Okay, and the sales column, here you can see the sales column has two missing values, two nan values. So what we can do is, here pass by equals to, and it is sales, by equals to sales, and then pass na underscore position equals to, if you suppose passed first, then what happens, here you can see the null values got printed at the starting of the column, here nan and nan. And let's copy this and print and paste it here, and here pass na underscore position equals to, and pass here last, and then you can see the null values got arranged at the bottom of the column, here nan and nan. So this is the way. Na underscore position will, you can give two parameters here, first and last. When you give first as parameter, then the null values will get arranged at starting of the column, and when you pass na underscore position equals to last, then the null values will get arranged at the bottom of the column. So this is the way to do it. Okay, and suppose you sorted your columns but you want your original column back. So what you can do is, so like create a variable named as shuffled. Okay, and here you want to restore your original data set. So here you can pass df.sample and pass frac equals, here you can pass any variable. Suppose I passed frac equals to 1, it will create a shuffled data set, and then restored equals to another variable, and you want shuffle dot sort underscore index, and then you can sort your values by their index number. And when you print restored, you can see your original data set got restored. Here you can see it got arranged by their index values 0, 1, 2, 3, 4 and 5. Here you can see we passed sort underscore index that arranges the data set in the index value. Like here you can see it got arranged by their index numbers. So this is the way to do sorting on columns. Next, let's move ahead at aggregation. So what is aggregation? So reduce multiple rows down to a single summary statistic. So what is this? Suppose you have a column and like salary column and it has many values. So if you want to sort, if you want to change or reduce that multiple values to a single value, what you can do is you can sum all the values, you can get mean of all those values, you can get minimum value of those. Suppose you have multiple values in a column, so you can get the minimum value, you can get the maximum value, you can count how many non-null values are there in the column, you can get the median, you can get the standard deviation, and you can apply aggregate function to do all these. How? Let's see. So aggregation. So first, let's print in traditional way. Suppose you want to print sum of any column. So print, and what you want to print? You want to print sum. Okay. And sum of what? You want to print sum of units. Okay. Like here you can see there are multiple values inside the units column and you want to sum all those values. So what you can do is pass here units and then provide dot sum method, and here just a second, here okay, sorry, here you can pass this way and remove this because we don't need it here, and then here dot sum method and close it and run this. Invalid syntax. What we missed is, oh sorry, here we need to, we forgot the comma here. Let's run this. See, the sum is 61. The sum of the values in the column units is 61. So this is the traditional way to do this. Okay, suppose you want to print mean or median. So how you can do is just copy this, paste it here, and just here you want, suppose you want mean, so write it here mean and dot mean. When you run this, you can see this is the mean value, and if you want median, what you can do is just paste it another time and dot here print median, and let's change this also as median, and when you run this, here you got the median value. So this is the traditional way to get sum or mean or median of values. So how you can do the same with the help of aggregation function? So let's see. So suppose you want statistical summary, stats underscore summary, create the variable and then use aggregate function. So here you want to apply aggregate function on units column. So first access the unit column and then dot agg for aggregation and then pass the methods. Suppose you want sum, okay, you want mean, then pass mean, you want like median, pass median, you want like standard deviation, then pass std, you want like minimum value, then pass min, you want maximum value, then pass max, and when you run this, okay, it got run, and print stats underscore summary. When you run this, you can see sum, mean, median, standard deviation, minimum and maximum value got printed. So here you can see you need to do it like separately. Here you printed sum separately, mean and then median, but with the help of aggregation function you can do all these calculations together. Here you can see dot agg function printed all these together: sum, mean, median, standard deviation, minimum and maximum value. And you can do it another way, like df dot describe, which we discussed in previous video. Df dot describe, and when you run this, here you can see the minimum value, the mean value, the standard deviation, the max value, the count. Like sale has 4 values, you know that sale has 2 missing values, so it counted it as 4. Otherwise unit has 6 values, sale has 6 entries, sales polynomial has 6 entries. So this is the way you can see here. Okay, now but the thing is, like here you don't get the sum value, so you can apply dot agg function to get all these entries. Otherwise, if you want a quick recap or quick summary, you can use df dot describe method also. Next is like you want to apply different aggregation functions to different columns. How you can, here you can see you applied different aggregation functions on a single column, on unit column, but you want different aggregation functions on different columns. So how you can do this? So like diff underscore columns is the variable, and let's start doing the df dot agg is the function, and pass inside in form of a dictionary. So first, suppose you want to apply agg function on like sales column, so pass here sales, and then provide the methods, like you want sum and you want like mean. Here you can say mean, then you want to apply this function on units, so pass here units, and then the ways, like you want min and max, so min and max. So this is the way to do it. You applied different aggregation functions on different columns together, and when you print this diff underscore columns, so here you can see the sales has sum as 830, mean is 207, min is nan, and max is nan. Units sum is nan, What is the problem here? Let's print df to see the problem. Df region product sales. Okay, sales has, if you sum the sales you will get 830. If you print the mean of sales, you will get 207. The min and max is none because maybe the null values here are bigger than the entries. Here you can see the max value is 300, but maybe the nan values are greater than this, so here you will get nan. So this is the way to apply aggregate functions on different columns. Next is group by. So what is group by? So group by is the split apply combine paradigm for grouped analysis. If you want to combine two or more groups together, then you can use group by function. You can do single key grouping, you can do multi key grouping. Like single key grouping is group by one column, and you can group by multiple columns, and you can use named aggregation for clear readable per column aggregation definition. We will look at this. So let's start group by function. So suppose you want to group, like here you can see this is the df, and you want to know that region and units together. You want to know which region sold how many units. So you can group by those columns. How? Let's see. So first define a variable region underscore total equals to, so here you need to df dot group by function, df dot group by function, and then pass the column name, that is region. Okay, and you want unit column also, units, and you want the sum of the units because you want to know which region sold how many total units, so you want sum of these. So here you need to pass dot sum, and when you run this and print region underscore total, here you can see that east region sold total 24 units, north region sold total 22 units, and south region sold total 15 units. So this is the way you can combine or group by two columns together. You can do with multiple columns also. And suppose you want more information about the product sale. So what you can do is, suppose you want to group by the region with product, like which region is selling which product type. So you can do it by first declare a variable and then apply df dot group by function, df dot group by, and then start passing the column names. So you want region and you want product, region and product, and you want to combine it or group by it with the unit sale. So units and dot sum, so that you can get the sum of total units sold. And let's run this and let's print the grouped variable group. When you run this, you can see that east region sold two products A and B. A got sold by 15 units, B got sold by 9 units. North region sells two units A and B. A got sold 10 units, B got sold 12 units. South region sells two products A and B. A got sold by 7 units and B got sold by 8 units. So you can compare like the product A is getting more sale in East region, the product B is getting more sale in North region, the product B is getting more sale in South region, or you can say it approximately equal 7 and 8. So you can say this. So this is the way to combine multiple columns or group by multiple columns with another column. Now suppose you want to get more information like how many total units sold, how what is the average sale, and you want row counts like how many products are there. So how you can do it, suppose first declare a variable result and then df dot group by function, df dot group by, and then start passing the values. So you want region, okay, and then you want to aggregate it, you want to aggregate it with, I will explain it first, and you want total values, total units sold, and that is equal to you can say number of units and pass units, and you can apply here the aggregation function sum. Okay, this is the way to do. Next, you want to know that what is the average sale. So average underscore sale equals to, you want to apply it on sales column, and the aggregation function that you want to use it mean. So here mean, then you want to know that product count means how many products are there. So you can like pro underscore count is product count, so equals to, and pass product, and then you want count method, you want to count how many products are there, so count. And when you run this, it got run successfully, and when you print result, let's see what happens. See here, you can see the East region total units sold is 24, average sale in East region is 240, and there are two products. North region sold total 22 units and the average sale is 200, and there are two products. South region sold 15 units, average sale is 150, and the product count is 200. So here you grouped columns like region column, and you applied aggregation functions to get more and more insights. You applied aggregate function on units column to know how many total units sold region wise. You applied average sales, you applied mean aggregation function on sales column to know what is the average sale in any region. You applied count aggregation function to know how many products are there. So you got this, like average sale in East region is 240. So you grouped region with these new columns. So this is the way to do this. Okay, so that's it for today, and after watching this video you will be able to handle missing values with the help of interpolation. You will be able to sort values in ascending or descending order inside a column. You will be able to use aggregation function to summarize large and larger data sets easily, and you will be able to apply aggregation functions like sum, mean, median, and minimum, maximum, standard deviation easily. Okay, and you will be able to use group by function so that you can group multiple columns together to analyze more and more insights about the data set. So that's it for this video. We will deep dive more into Pandas library in next video. So that's it for today. Thank you so much for watching.